Okay, hello Cloud Gurus, how y'all doing? I'm Scott Pletcher and welcome to another ACG project. ACG projects are little self-contained activities that you can usually complete within a weekend or less. And they're designed to give you a chance to roll up your sleeves, get your hands dirty, and learn something new. In this ACG project, we're going to take on multi-cloud. Specifically, we're going to create something which involves multiple public cloud providers. This project is my response to a Cloud Guru challenge that I hosted in January 2021. We'll link to my blog post announcing the challenge in the resources below, but that's not required reading for this ACG project. There were an infinite number of ways to complete that challenge, and I'll be walking you through how I did it. Now, this is not the solution, and certainly not designed to serve as some sort of immutable design pattern or reference architecture. Instead, I just lined up some frameworks and technologies that I really wanted to learn more about. And that's what ACG projects are really about, letting us venture down paths we wouldn't normally take. Now, if you'd like to get your flex on with your multi-cloud muscle, let's get started.
All right, let's get started with this multi-cloud madness challenge. The challenge is this: create a simple web app to upload a picture, use some image recognition service to extract metadata from that image, and then store that metadata in a NoSQL database. Simple enough, right? But there's a catch. We must use at least 3 different cloud providers to accomplish this task. And we can't take the easy path and just deploy some VMs or a pre-built Docker container. Here's what my architecture is going to look like. For my cloud providers, I chose AWS, Azure, and GCP. For my front end, I've been hearing some good things about the Vue.js framework being really handy for quick prototyping, so I decided to give that a try despite not having any prior exposure to it. That front end would capture an image and upload it to an S3 bucket on AWS, which is AWS's object store service. Once uploaded, I could use the event functionality of S3 to trigger an AWS Lambda function, which is their function as a service. Then in that same Lambda function, I can call out to Azure Computer Vision API, which is part of Azure Cognitive Services. And once I got that metadata back from the API, I could write it out to GCP's Cloud Firestore NoSQL database. Now, if I were designing this as a large industrial strength integration, you'd hear me talking about the need for layers of abstraction and canonical forms and middleware. But this isn't that sort of project. I'm going to use AWS Amplify to get the image into S3, and then a combination of REST and SDK calls to connect the other parts. And for the logic, I'm going to use JavaScript and Node.js. Now, here's what you'll need. Most definitely, you'll need logins to 3 cloud providers. If you're not sure how to create accounts, we have some quick, short videos on the ACG platform that walk you through the process. You're also going to need a webcam or a phone camera. Now, I've tested the front end with browsers on desktop computers as well as mobile devices using the Chrome browser. I can't really vouch for any other browsers, though. Now, you'll hate your programming life less if you pick up some code editor. Now, yes, Notepad has its benefits, but there are better options. I use Visual Studio Code, which is free, but there are plenty of other free and commercial options. And if you're hardcore and you want to use Vim or Emacs, be my guest. You also might want to install Git and Postman. Postman is a useful tool for testing REST interfaces. Okay, let's start with some basic setup. Now, for this project, you're going to need Node.js. And the easiest way I've found to manage all the different versions of Node.js that are out there is to use a utility called Node Version Manager. And you can go out to GitHub and download this script. And this script is going to allow you to select and download a very specific version of Node.js, whichever version you want. Now, since I'm going to be using AWS Lambda, I know that one of the versions that Lambda supports is version 12. So it's going to be important that I be sure that I'm using the same version that Lambda supports. So I want to get a list of all the version 12 versions of Node.js that are out there. I meant grep. And here we go. We have the latest one down there, version 12.20.1. And I can use nvm to install that specific version. Now that I have Node and npm, the Node package manager, installed, I'm going to use npm to install Vue, the Vue CLI, and the Vue CLI service global. And you'll notice that -G, and that just means it's going to install it as a global package, and I can access it no matter where I am in the directory structure. I'm also going to install the AWS Amplify CLI so that we could configure and manage our Amplify application. So I'm going to create a directory for us here and change into that directory, and that pretty much concludes all the prep work that we need to do before we start on the project. Just for posterity's sake, I'm going to show you the version of Git and Visual Code that I happen to be using. We're not going to be using any specialized features of any particular version, so I'm pretty sure any version will work. To create the Vue scaffolding for our front end, we just use the Vue CLI, and then we use create, and then whatever we want to name our application. And it's going to ask us some questions. I'm just going to go with Vue 2 here. And then it set up everything. So we can cd into that directory, and let's fire up Visual Code and see what there is. Now, what Vue created for us is just a template. It's a little hello world template. And we can cd into the source directory, and then using npm, we can run a little local server that's going to allow us to look at this web page. That's what it looks like. Not very exciting. Now, in this project, we're going to be making use of our webcam. And I found a really easy to use library for Vue that makes using the webcam pretty simple. So I'm going to install that right now. It's called Vue-web-cam. Now I need to configure a little Vue config file. And the reason I need this file is I need to tell that little local server to serve up pages using HTTPS. And that's important because if we want to use the webcam, we have to be using HTTPS. That's just a security feature of the browser. Now we're ready to set up Amplify, and we can do that using the Amplify CLI that we installed previously. We also need to log into the AWS console because it's going to need us to do some stuff in that console. So we can select the region that we're working on, and then we can also select the name of the Amplify user that we want to create. This is an IAM user that acts as sort of a service account. And we have to give it quite a bit of permissions. This is just part of the Amplify setup. I'm sure you could probably scale that back a bit, but I'm just going to go through using the default permissions. And this is a programmatic user only. So we're really interested in that access key and that secret access key. So Amplify's setup wants us to copy and paste that access key and the secret back here so that it can use that when communicating with AWS. I'm going to give it a specific profile here. And now our Amplify CLI is set up. And to create an Amplify application, we just use Amplify init. And then I'm going to just use the defaults here. It pretty much identified that I'm using Visual Studio Code, I'm using JavaScript, I'm using Vue, and it's familiar with those default paths. Now this is an important piece because I chose to create my own profile rather than the default. I had to tell it what profile I wanted it to use. Then it's going to go out there and create a bunch of stuff. I've greatly sped this up. And you can go out to the AWS console and see your application out there. And you'll notice that it sort of looks like Git in its command format. You can pull down, you can push back up from local to the cloud. You'll see us use that later. So now we're ready to add some Amplify components. And the first component I'm going to add is an authorization component. Now by default, it just uses Amazon Cognito, which is perfectly fine by me, but you could also use kind of a federation setup with maybe other social network providers. I'm going to want people to sign in using their username, and I don't want to mess with any of the advanced settings. Okay, so this has created the artifacts there locally that represent our authorization resource. Now I also want to add a storage component so that I can have some place to store my pictures. And I'm going to select content as the storage type. Then I have to give it some common sense name. Now I can also name my bucket. So in this case, I called it Pletcher Cloud Challenge. I'm going to only allow authorized users to do anything with this bucket, and they can create stuff, read stuff, and delete stuff. Now, the last question I'll get asked is, do I want to create a Lambda trigger for this S3 bucket? And right now I'm going to say no, because I want to manage that and I want to create that Lambda function using the Serverless Framework, which also allows me to create that trigger as well. Okay, now we're ready to push the configuration out to AWS, and we just use Amplify push. And now it's going to build and run a CloudFormation script. And this takes some time. I've greatly sped it up here. But ultimately, when the script is done, you will have an S3 bucket out there. You're going to have a Cognito user pool, and you're going to have all the bits and parts and pieces that you're going to need to interact using the Amplify libraries from this Vue application. Now I'm ready to customize the little Hello World template that Vue created for us. So I'm going to rename the component here to camera, and then I'm just going to paste in my code. Feel free to take some time to really go through this code and try to figure out what it's doing. Now, here's a disclaimer. I am most definitely not a very good JavaScript programmer. I'm pretty much a hack programmer, but hey, if it works, it works. So definitely don't use this as some sort of reference architecture, but I can tell you that it does work, and it seems to work pretty well, and it seems to incorporate most of what I've found as some of the best practices. You'll want to pay special attention to the method on upload. That's kind of the business end of the operation here. It's going to take the image that was captured from the webcam and then package that up and then send that to S3 using the Amplify SDK. I'm also going to replace the code that's in the app.vue file with my own code. I want to bring your attention to a couple things in this file. It's not a very big file, but the Amplify authenticator tags play a really important role because when this application gets rendered by the Vue server, the Vue build process, those little tags are going to tell it to render a login box for Amplify. And we'll see that a little bit later. I'm also going to have to put some additional pieces in the main.js file. And this is just going to tell Vue where to find the parts and pieces to use Amplify. Okay, we're almost ready to go, but for our application to work, we're going to have to install the Node modules that are being used by our code. For starters, we're going to have to install the AWS Amplify components. And that's different than where we installed them globally. We need to install them here locally within the scope of the specific Vue application that we're working in. We also want to install some UI components for Vue from Amplify. Now you notice that the links are now HTTPS, and you're going to click on those links and you're going to get this scary message in your web browser. And the reason is that our certificates aren't real certificates. They're just kind of fake certificates for local purposes. So you just need to click Advanced and just proceed. Now we get a login screen. Now, because we don't have an account, we have to create one. So I'm going to click on this little button down here, and I'm going to fill in all my details. Now, the email address is important. It should be a valid email address because by default, Cognito tries to send you an email with a code in it so that you can verify your email. You can change all those configuration settings inside Cognito, but for our purposes here, I'm just going to go with it. And quite amazingly, they guessed my phone number, 555-555-1212. Now I go check my email, and I should have received a confirmation code, and I just plug that confirmation code in here. And then after I've done that, I've created my user account that is now an authorized user. And now we're in our UI. It's a pretty simple UI. I can press the Capture Photo button, which will get a still image from the camera. And then when I want to try to upload it, I just hit the Upload Photo button. And that's going to try to upload it to S3. Such a handsome devil. And if we look down at the bottom of my little status bar, it says successfully uploaded. So now we can go out to our S3 bucket and let's see if it really truly is successfully uploaded. So here are the buckets that have been created for us. Now the top one, the Amplify Upload Image Dev bucket, is just used by Amplify behind the scenes as a sort of working space. Now the Get Image Data Dev Serverless Deployment bucket, that's for the next module. The Pletcher Cloud Challenge, that's the bucket that was created when we configured Amplify and added that storage component. So this is the one that Amplify is set up right now to upload images into. So I can drill into that, and eventually I'm going to find a JPEG. Now if I go and download that JPEG, hey, there I am. So it worked. So it seems like we have a working front end. We can get images from our webcam up to our S3 bucket. Now in the next module, we're going to talk about what we do with them once we land them on our S3 bucket. Now we're ready to focus on the back end. And for the back end, I wanted to try using the Serverless Framework. Now, I've never really done much with it, and I just never had an excuse to use it. And now I do, so I wanted to learn it. And I have to tell you, after just spending a little bit of time learning some of the key parts to it, it is very powerful and very useful. And so all those folks out there that have been using the Serverless Framework for a long time, they're probably like, well, yeah, of course it is. But for me, that's all part of this process is we have an excuse to go explore things that maybe aren't part of our normal day-to-day operations, and it just makes us better. It's how we learn. I'm going to change into our Cloud Challenge folder and configure our serverless application. I'm going to say no, that I don't want the free serverless account. And sure, we'll do the updates. It's a very short setup, and all it really creates for us are these two files. But these two files are really important, and we'll step through them. So probably the most important file here is the serverless.yaml file. And it has a bunch of boilerplate stuff in there, but I'm just going to clear that out and put the stuff that I need in there. This YAML file allows us to define our service, and we can specify who our provider is, who's going to be hosting this service, and each provider has their own little parts and pieces that need to go in there. Then we also define our function, and in this case, we're calling it the getImageData function. Now, the handler file that was also created, that's the code of the function that's going to be executed. So within our function, we want to define an event. And in this case, it's going to be an S3 event. And we define our bucket. The bucket name was defined earlier in the YAML code under the custom variables area. We also have some environment variables down below here, and we'll fill those in as we build out this back end. I'm also going to change out the code that's in the handler.js file. And this is the core code. This is what's going to really drive our Lambda function. Now, if you're not a programmer and this is the first time that you're looking at JavaScript code, it can probably be pretty intimidating, but I'm going to try to simplify it and walk you through what I'm doing so at least it maybe makes sense. It makes logical sense. Now, also keep in mind, though, that this isn't a course on how to write JavaScript or a course on how to write Lambda functions. We have a lot of great material on the ACG platform to help you out with that. But hopefully, if you're a true beginner, I'm going to give you an idea about what's going on here. And you should be able to pull this down and then kind of monkey with it a little bit and see what the results are and see how you go about trying to understand stuff. Starting up at the top is we have some constants defined. And these are some modules that we're going to be using further on down in the code. The first one up there is the AWS SDK. This is going to allow the Lambda function to reach out to S3 and pick up the file that we've stored there. The next one is Axios or wherever you hail from. I've heard it different ways depending on what your native tongue is and your accent is. But just know this. It's a library that's very useful for forming and making and receiving back REST calls. So the next item on the list is Google Authentication Library. Now, initially when I tried this, I wanted to be very pure and just use REST for everything. The further I got into calling Google resources, the further it became just a coding, the complexity just skyrocketed. And so one of the recommendations was to use this Google authorization library to help streamline things and simplify things. And boy, did it ever. And you'll see that come into play later. The next thing is a constant. We have an S3 object that we define, and that's just we're using the AWS S3 implementation of that. Next down, we have kind of the main routine or the main function of the function. It's the module exports get image data. Now, just to make things somewhat more easier to read and simplified, I pulled out some of the logic into other functions, that being the get image data function and the store data function. The get image data function is going to call out to our Azure service. The store data function is going to store that data in our GCP data store. Now, inside the main kind of worker space for the function, we have a for each loop set up. And this is just because events coming from S3 come as an array. That just means there can be multiple items that come through when that event is fired. So I have to be sure to accommodate that. And I just created a for each loop here that will process each item in that array. Now, I also use the S3 get object method as a promise, and this just helps me chain together some stuff. And for me, it just makes more sense. And this is one of those JavaScript Node.js things that stylistically you'll see all sorts of manner of doing the same thing. This is just the method that I chose to use. And in our case here, once I got that object back, that image back, I want to hand that image over to the next step. And in our case, it's the get image data, which I pass the image itself. And if you recall, I created that async function, the get image data function, that's going to call out to our Azure service. And once we get the results back from that get image data function, then I hand that off to the next step in the chain, which is storing that data. That then calls the store data function, which is its own call out to GCP. I know this seems really, really complex, especially if you're not familiar with looking at this code, but just spend some time with it and kind of deconstruct it a bit. I'm also going to create a file that's going to help us test this function locally. Now, one of the things that I have learned in the past with my experience with serverless is it's kind of a pain in the neck to troubleshoot because you got to upload it to the cloud and then use whatever instrumentation the cloud provider has to try to figure out what went wrong. I would just much rather do my debugging and troubleshooting locally before I push it to the cloud. So we can create an event.json file, which is sort of a stand-in for the event that we're going to configure S3 to fire, which will trigger this Lambda function. This basically mimics the data that our Lambda function would receive when somebody uploads or puts a file, an object, in that S3 bucket. For this event.json, I've hard-coded in the path to our upload that we did when we were preparing our front end. So it's a perfectly valid file that lives out there on S3 that we can try to get this function to reach out and grab. For our testing purposes here, I'm going to comment out some of the calls further on down in the process just to make sure everything's working okay with the first part of it, which is grabbing that S3 file. Now, if I want to be able to test this locally, I have to install the AWS SDK. And while I'm at it, I might as well go ahead and install the Axios library and the Google authorization library. All right, now we're ready to try to invoke our function locally. We give it a path to the event.json and tell it which AWS profile we want it to use. And failure. Error. Specified bucket does not exist. Let's go see what may be causing that. I see it here. I failed to upload this with the proper name of my bucket. So it's pretty easy. I'm just going to copy the name over. And here we go. Let's try it again. Well, at least we didn't get an error. Let's move on to setting up the Azure components. We go out and log into the Azure console, and we're going to go to this create a resource icon. We're going to search the marketplace for computer vision. And then we're going to create. And we're going to create a new resource group. And this is just how Azure groups things together. We're going to specify a name. And the pricing tier, we're going to use the free tier. Now it's going to validate what we put in. Everything looks cool. We're going to create it. And in a few moments, we're going to have those resources created for us. And we can drill into them. Now, there's a lot of great documentation out here with how to make use of this API, and you can spend some time exploring that. But what we're primarily interested in here is we want to try to get our keys and endpoints. This is going to be how we can reach this service. We have an endpoint for this API that's been created for us, and we can take that and paste that into one of our environment variables so we can access it from our code. Now, similarly, we can grab one of our keys and then paste that into the environment variable for our key. Now we have our API endpoint that was generated for us, but we still have to figure out what we want to use that API to do. So we go out to the documentation for that API. And in our case, we want to analyze this image. So I can see to use that analyze method, I need to add this little bit to the end of my endpoint URL. Now, additionally, we can optionally include this visual features request parameter. That's going to tell us what sort of analysis we want to do. In our case, I want to get some tags back. A lot of times when I'm working with REST APIs, I like to use a tool called Postman. And that just is a pretty user-friendly way of formulating REST API calls and just testing them out to see what works and what doesn't. So in this case, I've got the proper URL and I've included the required headers and parameters. And for the body, I've included a binary file of the photo of me. Then I can send that request and we'll get back a response from that API. Now, a nifty thing about Postman is it has this little code snippet feature. So based on how you built your REST call, it can generate some suggested code for whatever language and libraries you might be using. So in our case, it created this little stub that mimics what our request was. And that was very beneficial when I was trying to figure out what the config needed to look like for that call out to the REST service. Okay, for our local test to work, I need to add that little bit to the end of our Vision API. And I'm just going to include a little console log statement here so we can see what actually gets returned. And there we have the response back from the API based on the file that is living out on S3. All right, we are ready now for the Google Cloud Platform components. And once you get logged into the Google console, it's going to hassle you to create a project. And unless you have a project, you really can't do anything else. So most definitely create a project. And again, a project just as a way that GCP keeps things nice and neat and kind of related. You can have multiple projects. I'm just going to give it a name here, Cloud Challenge. After a few minutes, the project is going to be created. Then we can go out to Firestore. Now, Firestore has two methods, and I'm going to choose the native method in this case. I'm going to choose NAM5 as the location, and then we're going to create our database. Now, the database creation process will take a few minutes. So now we can create our collection, and collection is kind of similar to like a table in a traditional database. Now, for document ID, I'm going to let it give us unique document IDs. I am, however, going to create a field name called image path and another field name called image metadata. And these are just going to be string types. So there we have our first entry into our NoSQL database. Next, I want to go over to IAM. That just stands for Identity and Access Management. Then I'm going to go to Service Accounts. I need to create an account that I can actually write stuff into this database. Create Service Account. I'm going to give it some name. Give it a description, create it. I'm going to select the role to be Firebase Rules System. Then continue. And we have our service account created. Now I need to go into that account and get its key or generate a key. So I'm going to add a key, create new key, and I want to download as JSON. Now this JSON file is going to contain some private keys inside that are going to allow me to authenticate into GCP to do certain things. And here's what it looks like. Now I can update the environment variable that points to the path of this special key file. And this special key file is going to be used by that Google authentication library to get some authentication tokens so that we can call our REST service. Another thing I need to change is the Firestore API URL. I need to include the project ID as part of the path. And also the name of the collection as part of the path too. I'm going to uncomment the parts that actually call out to Google. This part right here is what's way simpler than trying to do all this stuff purely with REST back and forth between GCP. So using that helper library, that Google Auth library, I can very simply create a client request and then use that in my REST submission. And really all it does is just generates a kind of on-demand bearer token that gets inserted into the headers of the config data structure that I'm sending via the Axos library. So let's give it a go. All right, well, we didn't get any errors. Let's go check out the database. Whoa, look at that. We have a new record, and it has data in it. That's good. Looks like it has our data in it. Yep, that looks like the string that we got from the Azure API. Now I'm going to delete these records. I wanted to arrange things kind of side by side so we can see how fast it updates. So yeah, pretty much within a second. That was real time, what you saw there. So this is good news. This means that we have our function working at least locally. Now the next step is going to be to deploy it to AWS. That's pretty simple, serverless deploy. And we of course give it the AWS profile that we want to use. Uh-oh, error. After searching around a bit, I went back to my serverless YAML, and sure enough, I had failed to update the bucket name with a valid bucket name. And I'm just going to put in the bucket that Amplify created for me. And success. We were able to successfully deploy it. If we go out to the Lambda console, here's our function right here. We can go into it. But let's test it out. So if I go back to my upload image folder and I kick off the server process that's going to host our code for the front end, I'm going to delete these items. We are presented with a login. This is our Amplify login. I enter my username and the password, and there I am. Captured the photo. I'm going to upload the photo. It was successfully uploaded. Wait for it. There it is. So that was real time. It was about maybe 2 seconds from the time we upload the photo to the time that that data got saved into the GCP data store. Try something different. Upload. There we go. Yeah, 2 to 3 seconds. Not bad. All right, we're working end to end. We are working. Boy, that feels good.
So we did it. We managed to build an application that spans across 3 different cloud providers using, at least in my example, 10 different services and frameworks, some of which were totally new to me. I learned lots and feel like I now have more familiarity with Vue, Amplify, the Serverless Framework, the Azure Cognitive Services, and GCP Firestore. I also learned plenty along my many detours that I didn't cover in this video. I went down an Angular path before I changed over to Vue. I somehow got waist deep in Firebase before I realized that I could do what I needed just with the Firestore API. And I think that's oh so important as well. It's not about all the things that you learn while you're taking the happy path. It's all those collateral learnings that you get when you try to do something that you've never done and you're just not sure how to do it. I had lots of fun with this one and hope you did too. If you have suggestions for other ACG projects, be sure to leave us a comment or drop us a line. Until next time, stay safe, take care of one another, and keep being awesome, cloud gurus.